As we prepare to move deeper into this mystery, to leave the bright city lights of the inner galaxy and head towards the soft, fading outskirts, I want to leave you with a question to carry with you into the quiet of the night, a question that will guide our exploration. If we can't find a wall, a sign, a fence at the edge of our galaxy, what does that tell us about the very nature of home? Now, close your eyes for a moment if you'd like. Let the image of that starry disk fill your mind. But instead of seeing it as a flat picture, feel it as a place, a realm. And imagine you are a traveler, setting out from our quiet suburban solar system, heading not inward toward the brilliant, crowded core, but outward, toward the frontier. Your ship, let's just let it be our imagination sails past the familiar constellations. You glide beyond the Orion Spur, our local neighborhood, and the density of stars begins to slowly, imperceptibly, change. It's not sudden. It's like watching a crowd thin out after a great event. The bright, young blue giants, the massive stars that live fast and die young, they become fewer. The space between stars grows wider, darker, more profound. You are now moving through the outer disk. Here, the spiral arms are more suggestion than structure. They are like great, lazy swirls in a cosmic cup of coffee, traced not by solid lines, but by a slightly higher density of stellar nurseries and the faint, radio wave glow of hydrogen gas. This gas is the raw, unformed potential of the galaxy. It is the reservoir from which future stars will be born. And out here, it is colder, quieter, more diffuse. And then, you reach a point where the last, faint, reddish dwarf stars are like distant campfires in an immense, dark wood. This is what we have long called the edge of the stellar disk. On a map, this might be labeled as 50,000 light-years from the center, a hard number, a boundary. But you look at your instruments, and you look out the window, and you see that the journey is not over. The campfires are still there. They are just so far apart now that the darkness between them is vast and deep. One every few hundred light-years, perhaps, then one every 1,000. These are the first outposts of the halo. This is the first great revelation of our journey. The edge of the bright disk is an illusion. It is merely the point where our human eyes, and even our telescopes, have a hard time seeing the light. But the galaxy's population of stars does not obey our cartographic desires. It fades, it thins, but it does not stop. And these stars out here, they are different. They are not like our sun, a relatively young star, rich in heavy elements forged in the hearts of long-dead ancestors. Many of these halo stars are ancient. They are population to stars, incredibly old, metal-poor relics from the galaxy's violent infancy. They are the senior citizens of the Milky Way, and they carry in their spectral lines the chemical fingerprints of a time before the disk even formed, when the galaxy was a great, chaotic cloud of gas, collapsing in on itself. Their orbits are different, too. They don't circle neatly in the plane of the disk like cars on a racetrack. Their paths are wildly eccentric, tilted, plunging them high above and far below the galactic plane on long, slow, looping journeys that can take hundreds of millions of years. They are the wanderers, the nomads, the ones who remember when the galaxy had no defined shape. As you travel among them, the silence deepens. The combined light of the distant disk is now a great, glowing wheel behind you, a celestial city seen from a far-off mountain, and ahead, only blackness. But your instruments are picking up something else, not the faint light of stars, but the subtle, gravitational tug of something else, something immense. This is where our simple journey outwards becomes a journey into the invisible. This is where we meet the ghost in the machine, the mystery of dark matter. Imagine you are in a room that is completely, utterly dark. You cannot see your hand in front of your face, but you can hear a large, heavy object, a grand piano, perhaps swinging back and forth on a pendulum. You can hear the whoosh of its passage. You can feel the disturbance in the air. You can sense its immense weight and momentum. You know, with absolute certainty, that something is there, something massive and powerful, even though you cannot see it. This is precisely how we discovered dark matter. We saw the stars, especially those in the outer galaxy, swinging around the center at tremendous speeds. By measuring their velocities, we could calculate how much mass must be inside their orbits to hold them in place, to prevent them from simply flying off into intergalactic space. The numbers didn't add up, not even close. The amount of mass we could see in stars, gas, and dust was only about 10% of what was required. There had to be 10 times more matter, completely invisible, providing the gravitational anchor for the entire galaxy. This missing mass, this dark matter, forms a vast, spherical halo that extends far, far beyond the last visible star. Its gravitational influence is the grand piano swinging in the dark room of our galaxy. We cannot see it, but we feel its pull in the very fabric of space and the motion of every star. Think about that for a moment. The Milky Way we see, all 100 billion stars, the great spiral arms, the glowing nebulae is just a froth on the surface of a deep, dark ocean. The visible galaxy is merely the decoration, the illuminated tip of an iceberg whose true, massive bulk lies hidden in darkness. This dark matter halo is not a small thing. Current estimates suggest it may extend up to 1 million light-years from the galactic center. Let that number settle in your mind. 1 million light-years. Our entire bright disk, 100,000 light-years across, would fit neatly inside this invisible sphere with room to spare. Our home is not a flat disk. It is a colossal sphere of unseen force, with the beautiful spiral structure nestled at its heart like a precious jewel. And this is where the concept of an edge becomes truly, fundamentally blurred. Where does the dark matter halo end? Does it ever? Its density decreases with distance, but in theory, it just keeps fading, becoming ever more tenuous, until its gravitational influence is lost in the general background hum of the universe. There is no sign, no fence, no boundary. There is only a gradual lessening, a gentle release. But the mysteries of the halo do not end with dark matter. There are other ghosts out here, other echoes. If you listen closely with the right instruments, you can find them. Great, shimmering rivers of stars flowing through the darkness. These are tidal streams. They are the ghostly remnants of smaller galaxies that ventured too close to the Milky Way and were torn apart by its immense gravity over billions of years. The most famous of these is the Sagittarius stream. Once, there was a small dwarf galaxy orbiting our own. With each pass, our galaxy's gravity pulled it apart, stretching it like cosmic taffy into a great arc of stars that now wraps around the Milky Way like a faint, celestial ribbon. We are, in a very real sense, a cannibal galaxy. We grow by consuming our smaller neighbors, and these streams are the archaeological evidence, the stellar DNA of our past meals. They are beautiful and haunting. They tell us that our galaxy is not a static, isolated island, but a dynamic, evolving entity, still growing, still shaping itself through violent, slow-motion mergers. And as you drift here, in the profound quiet of the galactic halo, surrounded by ancient stars, tugged by an invisible force, and crisscrossed by the ghosts of consumed galaxies, you might look out into the true blackness ahead, and you might see two faint, fuzzy patches of light. They look like pieces of the Milky Way that have drifted away. These are the large and small Magellanic Clouds. They are our largest satellite galaxies, orbiting our own like moons around a planet. They are our immediate neighbors, bound to us by gravity, part of our local family. They are a clear sign that even out here, at the very limits of our galaxy's influence, we are not alone. For most of human history, the center of our galaxy was a complete mystery. When we looked toward the constellation of Sagittarius, we saw a region unusually rich with stars, a great, glowing cloud of light. But we saw no further. A thick, impenetrable fog of cosmic dust blocks our view. Invisible light. It was like trying to look into the heart of a storm cloud from the outside. We knew something was happening in there, but we couldn't see what. It's only in the last few decades, with telescopes that can see in other types of light, infrared, radio waves, X-rays, that we have been able to pull back that curtain. And what we found there was beyond anything we had imagined. The galactic center is a place of extremes. It is the most crowded, chaotic, and energetic place for thousands of light years in any direction. Stars are packed together so tightly that if you lived on a planet there, your night sky would be lit with a perpetual, brilliant dawn, with stars so close they would be mere light days or light weeks away, not light years. It is a stellar metropolis, a Manhattan of the cosmos, where the skyscrapers are stars, and they are all jostling for space. And at the very, very center of this stellar metropolis, in the absolute core of this cosmic storm, lies the storm itself, a gravitational monster, a supermassive black hole we have named Sagittarius or asterisk. Our journey tonight is a pilgrimage to this invisible titan. We will sail through the dusty veil, navigate the crowded stellar city, and stand at the edge of the ultimate boundary, where space and time themselves come to an end. We will discover how this place of profound darkness is also, paradoxically, essential to the life and structure of our galactic home. So, let's begin. Let's turn our ship away from the quiet, dark outskirts and point it toward the bright, inner glow. Let the gentle hum of the ship's engines match the rhythm of your breath. We are going inward. The first part of our journey will feel familiar. We are still in the disk, in the spiral arms. We pass by star systems not unlike our own. But as we travel, the scenery begins to change. The space between stars shrinks. The background glow of the galaxy brightens. We are sailing into the more densely populated urban districts of the Milky Way. We are now passing through what astronomers call the galactic bulge. This is not the flat disk of the spiral arms anymore. This is a vast, three-dimensional cloud of stars, a great, swelling hub that rises thousands of light years above and below the galactic plane. It is roughly spherical, like the core of a great city from which the sprawling suburbs of the spiral arms extend. The stars here are different from our sun. Many are older, cooler, redder. They are population to stars, ancient citizens of the galaxy that formed long before the spiral arms settled into their graceful patterns. They are the old guard. Their orbits are not the neat, circular paths of the disk stars. They move in more random, elongated orbits, buzzing around the center like a great swarm of bees. The light here is a warmer, more golden hue, dominated by these red giants and older stars. It feels older. There is a sense of deep time here, of a history that predates our solar system by billions of years. And the dust is now becoming a real presence. Great, dark tendrils of cosmic soot begin to drift past our ship. These are not the wispy cirrus clouds of the outer disk. These are thick, dark molecular clouds, the kind that can completely blot out the light from stars behind them. We are sailing into the fog. This is the Great Rift, a series of these dark, obscuring dust lanes that we can even see from Earth with the naked eye, cutting across the bright band of the Milky Way. From our new perspective, it's no longer a faint line. It is a landscape, a range of dark mountains we must pass through to reach the inner sanctum. Our ship's, which is its view to infrared, visible light cannot penetrate this dust, but longer, heat-sensing wavelengths can. The world outside our window transforms. The dark clouds become semi-transparent, glowing with a faint, warm light of their own, and behind them, the true heart of the galaxy begins to reveal itself. It is staggering. The number of stars is beyond counting. They are not scattered points of light anymore. They are a continuous, blazing carpet of gold and orange. It is like flying over a vast, sun-drenched city at night, where the lights of individual houses and streets have merged into a single, brilliant sheet of illumination. The core of the bulge, now visible ahead of us, a concentrated, almost unbearably bright ball of stars. This is the inner parsec, a region just a few light years across. And here, the rules of normal space break down. The density of stars is millions of times greater than in our neighborhood. Stars here are not light years apart. They are light days apart. A trip from one star to its nearest neighbor would take a matter of weeks at the speed of light, not years. The gravitational environment is a chaotic dance. Stars whip around at terrifying speeds, their paths bent and twisted by the combined gravity of thousands of their closest neighbors. We can see young, massive stars here, which is a profound puzzle. The fierce radiation and powerful stellar winds in such a crowded environment should have prevented these stars from forming. Their presence is a clue that the environment here is not just dense, but dynamically violent, with forces compressing gas clouds into new stars against all odds. And at the very center of this stellar whirlpool, there is nothing, a point of perfect darkness, an absence. But the stars tell us what is there. We can watch them, over years of observation, as they trace frantic, slingshot orbits around this empty point. One star, known as S2, completes a full orbit in just 16 years. At its closest approach, it swings around at a blistering 3% of the speed of light. The only object that can cause a star to move like that is something of almost unimaginable mass, compressed into a point of zero volume. Sagittarius asterisk, our supermassive black hole. It contains the mass of 4 million suns. But it has no surface. It is not a solid object. It is a region of space, defined by its event horizon, one-way boundary from which not even light can escape. It is the point of no return. We cannot see it directly. How do you see something that emits no light? But we can see its shadow. We can see the ghostly outline of the hole it punches in the bright background of hot gas, and we can see its ferocious appetite. Because, despite its name, a black hole is not an empty vacuum cleaner. It is a dynamic engine, as gas and dust from the surrounding region are pulled inward by its immense gravity. They don't fall straight in. They spiral in, forming a vast, flattened, superheated structure called an accretion disk. The material in this disk rubs against itself, creating immense friction, heating it to millions of degrees. It glows, not with the gentle light of a star, but with the fierce, hellish glare of X-rays and gamma rays. Occasionally, the black hole feeds a particularly large cloud of gas, or perhaps a star that wandered too close, is torn apart by tidal forces. As this material spirals into the abyss, it heats up to incredible temperatures, and the black hole erupts in a brilliant flare of high-energy radiation. It is a brief, violent outburst from a sleeping monster. This is the great paradox of the galactic center. This place of ultimate destruction, this cosmic predator, is also a creator. The immense energy it releases, the powerful shockwaves from its flares, and from supernovae in the crowded core, can trigger new waves of star formation in the surrounding gas clouds. It shapes the orbits of the billions of stars in the bulge. Its gravity is the primary architect of the entire central structure of our galaxy. The supermassive black hole is not just a tenant in the city center. It is the city's founder and its master planner. Without this dark heart, the Milky Way as we know it would not exist. So, as we float here, at the edge of this magnificent, terrifying, and beautiful region, we are left with a new understanding. The center of our galaxy is not a single object. It is a relationship. It is the dynamic, violent, and creative interplay between a monster and its court, between the absolute darkness of Sagittarius asterisk and the brilliant, frenetic dance of the stars it holds in its thrall. Occasionally, the black hole feeds a particularly large cloud of gas, or perhaps a star that wandered too close, is torn apart by tidal forces. As this material spirals into the abyss, it heats up to incredible temperatures, and the black hole erupts in a brilliant flare of high-energy radiation. It is a brief, violent outburst from a sleeping monster. This is the great paradox of the galactic center. This place of ultimate destruction, this cosmic predator, is also a creator. The immense energy it releases, the powerful shockwaves from its flares, and from supernovae in the crowded core, can trigger new waves of star formation in the surrounding gas clouds. It shapes the orbits of the billions of stars in the bulge. Its gravity is the primary architect of the entire central structure of our galaxy. The supermassive black hole is not just a tenant in the city center. It is the city's founder and its master planner. Without this dark heart, the Milky Way as we know it would not exist. So, as we float here, at the edge of this magnificent, terrifying, and beautiful region, we are left with a new understanding. The center of our galaxy is not a single object. It is a relationship. It is the dynamic, violent, and creative interplay between a monster and its court, between the absolute darkness of Sagittarius asterisk and the brilliant, frenetic dance of the stars it holds in its thrall. We came looking for an engine, and we found a heart, a dark, powerful, beating heart that pumps not blood, but gravity and energy throughout the body of our galaxy. And this brings us to a final, soothing thought. As you drift towards sleep, we live in the quiet suburbs of this great metropolis. We are protected by distance from the ferocious energies of the core, but we are still connected to it. Our sun's slow, 250 million year orbit around the galaxy is, in the end, an orbit around the great, dark anchor in the heart of the storm. Imagine you are standing in a vast, dark field. It is a quiet, windless night. Above you, the sky is not still. It is alive. Each star is not merely a static diamond pinned to black velvet. If you could listen with something deeper than your ears, you would hear it. A slow, rhythmic thrum, a vibration, a pulse. Each star has its own unique rhythm. Some beat fast and frantic, like the wings of a hummingbird. Others throb with a slow, deep, primordial cadence, like the heartbeat of a sleeping giant. This pulse is the story of a star's life. It is the outward sign of an immense, balancing act happening deep within its core. Titanic struggle between the crushing force of gravity, trying to pull everything inward, and the explosive power of nuclear fusion, fighting to push everything outward. For millions, even billions of years, this balance holds. The star shines, it lives. But what happens when the balance breaks? Tonight, we will follow the life of a star. Not just any star, but a star much like our own sun. We will witness its quiet birth in a forgotten cloud of gas, its long, stable life of brilliant light, and its eventual, inevitable death. But this is not a story of an end. It is a story of a transformation so violent, so beautiful, and so fundamentally creative that it seeds the cosmos with the very ingredients for worlds, for oceans, and for life itself. We often think of space as empty, silent, and cold, but it is a nursery and a graveyard, a continuous, slow-motion explosion of creation and recycling on a scale so grand our minds can scarcely comprehend it. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all of it was forged in the heart of a star that lived and died long before our sun, was even a glimmer in a cloud of dust. We are literally made of stardust. This is not poetry, it is astronomy. So, let us begin our story at the very beginning, in the deepest, coldest, and most silent places of our galaxy, in the places where light has not yet been born. Let your imagination drift there with me, to the great, dark molecular clouds. The void between stars is not entirely empty. It is filled with a thin, diffuse mist of gas, mostly hydrogen, the simplest and most ancient element. Here and there, this mist gathers into vast, dark clouds, light years across. These are the celestial womb. They are cold, only a few degrees above absolute zero. And they are dark, their thick dust blocking the light from the stars behind them. They are places of profound quiet and patience. Inside one of these clouds, a slight ripple passes through. Perhaps it's the shock wave from a distant supernova explosion, a death rattle from a star that lived long ago. Perhaps it's the gentle gravitational nudge of a passing star. Or perhaps it is simply the random, slow dance of the universe, a place where density fluctuates by chance. In one particular region, a knot of gas and dust feels a slightly stronger pull inward. Gravity, that most patient and relentless of forces, begins its work. Atoms of hydrogen and spakes of dust start a slow drift toward a common center. This process takes hundreds of thousands of years, an imperceptible drift, but as the cloud contracts, it heats up. The potential energy of falling is converted into kinetic energy, into motion, into warmth. The core of this collapsing cloud grows denser and warmer. It begins to rotate, slowly at first, then faster, flattening into a disco protoplanetary disk, the future home of planets. At the very center, the pressure and temperature become astronomical. Hydrogen atoms are squeezed together with unimaginable force. They collide, they fuse. In a flash of energy that ripples through the core, a new nuclear furnace ignites. A star is born. The newborn star, what we call a protostar, does not shine steadily at first. It flickers. It belches great jets of material from its poles, piercing the darkness like cosmic lighthouses. It is a violent, messy, and glorious entrance into the cosmos. Finally, the stellar wind from the new star blows away the remaining cocoon of gas. The star emerges, shining with its own light. Its balance is achieved. Gravity and fusion have reached a stalemate. And this stalemate will last for billions of years. This is the main sequence, the long, stable adulthood of a star. For a star like our Sun, this period lasts about 10 billion years. It is a time of remarkable constancy. Every second, in its core, 600 million tons of hydrogen are fused into 596 million tons of helium. The missing 4 million tons of mass are converted directly into energy, as per Einstein's famous equation, E equals mc. This is the star's heartbeat. This is the source of its light, its warmth, its life. And this energy, created in the heart of the star, takes a long, arduous journey to reach the surface. A single photon, a particle of light, might be absorbed and re-emitted trillions of times over 100,000 years before it finally bursts free from the stellar surface and races out into space. The sunlight that warms your skin today began its journey during the time of early humans. Our star, our Sun, is in the middle of this long, stable main sequence life. It is a reliable, steady presence, but this stability is a temporary illusion. The balance cannot last forever. The star is slowly, inexorably changing. In its core, the hydrogen is gradually being depleted, turned into inert helium ash. This ash settles in the center, a core that grows heavier and denser. With less hydrogen fuel in the very center, the balance wavers. For a moment, gravity gains the upper hand. The core contracts, heating up even more. This new heat ignites hydrogen fusion in a shell around the helium core. This new, more powerful fusion pushes the outer layers of the star outward with immense force. The star begins to swell. It is leaving its main sequence life. It is becoming a red giant. Our own Sun will undergo this transformation in about 5 billion years. It will expand until its outer layers engulf the orbits of Mercury, Venus, and likely even Earth. The sky of our planet, if it still exists, would be filled with a bloated, red, dying sun. The oceans will boil. The rock will melt. It will be the end of the world as we know it. But for the star itself, this is not an end. It is a new phase of life, a violent and beautiful one. Inside the star, the core of helium ash is now being crushed by the weight of the entire star above it. It is getting hotter and denser. The temperature soars to 100 million degrees. And then, a new, more violent fusion process ignites, the triple alpha process. In a sudden, explosive flash, helium nuclei fuse together to create carbon. For a brief time, the star finds a new balance, fusing helium in its core. But this fuel, too, is finite. The process repeats. The helium in the core is exhausted, turning to carbon and oxygen ash. The core contracts again. Helium fusion ignites in a shell around the carbon core, while hydrogen fusion continues in a shell further out. The star becomes a complex, layered onion, with each layer fusing a different element. It is now living on borrowed time. Its fate is sealed by its mass. For a star like our Sun, this is where the final act begins. The core of carbon and oxygen will never get hot or dense enough to ignite fusion. It is the end of the line. The fusion shells become unstable. They pulse, causing the star to shudder and vibrate. With each pulse, it blows more of its outer layers into space. The star is gently shedding its own atmosphere, creating a beautiful, glowing shell of gas around itself, a planetary nebula. These are some of the most breathtaking objects in the universe, great cosmic butterflies emerging from their stellar chrysalises. The Helix Nebula, the Ring Nebula, they are the final, parting gifts of dying suns, and at the center of this beautiful nebula, the hot, exposed core of the star remains, a white hot sphere of carbon and oxygen, compressed to incredible density. A single teaspoon of its material would weigh tons on Earth. This is a white dwarf, the dying ember of a star. It has no fuel left to burn. It shines only with the leftover heat of its former life. A brilliant, Earth-sized diamond that will slowly, over trillions of years, cool and fade to a black dwarf, a cold, dark crystal in the void. This is the peaceful end of a quiet star. But for stars much more massive than our Sun, the end is not peaceful. It is the most violent and creative event in the universe, a supernova. Let us follow the life of a giant, a star born with 8 times the mass of our Sun or more. Its life on the main sequence is brilliant, blue, and short, only tens of millions of years. It lives fast and burns hot. Inside its core, the fusion process does not stop at carbon. The core, crushed by immense weight, becomes hot enough to fuse carbon into neon, neon into oxygen, oxygen into silicon, and finally, silicon into iron. This is the end of the line. Fusing iron does not release energy. It consumes it. The star's core, now an iron ball, has no more energy to give. It is a dead weight. In less than a second, the balance that held the star up for millions of years shatters. Gravity wins. Catastrophically, the iron core, unable to support its own weight, collapses. It falls in on itself at a quarter the speed of light. In a fraction of a second, a core the size of Earth is crushed into a ball of neutrons just a few miles across. The density is so immense that the very atoms are destroyed. Their protons and electrons force together to form neutrons. The collapse rebounds. The inrushing material hits the newly formed, impossibly dense neutron core and bounces outward. A shock wave, fueled by a torrent of ghostly particles called neutrinos, ripples out through the star. The energy released is beyond comprehension. In a few moments, a single supernova can outshine an entire galaxy of 100 billion stars. The star is torn apart. Its outer layers are blasted into space at nearly the speed of light, seeded with all the new elements, forged in its final moments and in the fireball of the explosion itself. Gold, platinum, uranium, silver, all the heavy elements in the universe are created in these few cataclysmic seconds. What remains is a neutron star, a city-sized object so dense that a single sugar cube of its material would weigh as much as all of humanity. It spins rapidly, often beaming radiation like a cosmic lighthouse, becoming a pulsar, or, if the original star was massive enough, the collapse does not stop at a neutron star. It continues until the core becomes a black hole, a gravitational pit from which nothing, not even light, can escape. This is the true legacy of the stars. Their death is not an end. It is a scattering. Now, imagine you are an astrophysicist, and you decide to calculate the speed of those outer stars, based on the immense, glowing mass of the galaxy. See all those stars in all that gas. You apply the laws of gravity, the same laws that govern the orbits of planets around our Sun. You expect a specific result. The stars on the fringes, far from the central pole, should be moving slowly. Their orbital velocity should drop off. A gentle cosmic slowdown dictated by the visible mass within their orbit. You point your telescope. You measure the light from those distant stars. You analyze their Doppler shift, the subtle reddening and bluing of their light that reveals their motion. And you discover something that should be impossible. The stars are not slowing down. They are racing. They are hurtling around the galactic center at velocities that defy all prediction. The outer stars of the galaxy are moving just as fast as the inner stars. The rotation curve is flat. This is not a minor discrepancy. It is a fundamental crisis. According to everything we know, these stars should be flung off into the intergalactic void, their centrifugal force overcoming the weak gravitational grip of the visible galaxy. The galaxy should be tearing itself apart, but it isn't. It is stable. It is holding together. There is only one conclusion. As unsettling as it is inescapable, there is more to the galaxy than what shines. Vastly more. There is an immense sphere of something enveloping the luminous disk, a form of matter that does not emit, absorb, or reflect light. It is completely and utterly dark, yet its gravitational pull is the dominant force, the invisible glue holding the galaxy together. We have named this mystery dark matter. Tonight, we will venture into this profound darkness. We will follow the trail of clues that led to its discovery. We will explore the ghostly halos it forms, the cosmic web it weaves, and the frantic, global hunt to identify its true nature. This is not a story about what we know. It is a story about what we don't. And it begins with a single, impossible observation, a galaxy that spins too fast for its own good. Let us rewind the clock to the beginning of this mystery. The year is 1933. Swiss astronomer named Fritz Zwicky is studying the Coma Cluster, a dense gathering of over 1,000 galaxies, millions of light years away. He measures the velocities of individual galaxies within the cluster and finds they are moving extraordinarily fast. So fast, in fact, that the combined gravitational pull of all the visible matter in the cluster should be insufficient to hold them together. The cluster should have dissipated eons ago. Zwicky proposes the existence of dunkel materie, dark matter, to provide the missing gravitational anchor. His idea is largely dismissed. The case goes cold for decades. Then, in the 1970s, an American astronomer named Vera Rubin picks up the trail. Using more sensitive instruments, she meticulously maps the rotation curves of spiral galaxies. Her data is undeniable. Galaxy after galaxy exhibits the same bizarre flat rotation curve. The evidence for unseen mass is no longer a curiosity from a distant cluster. It is a universal feature of spiral galaxies. The mystery is real, and it is everywhere. The hunt is on. Our first task is to map the shape of this invisible presence. We cannot see it, so we must trace its outline using the things we can see, stars and gas. We become cosmic cartographers of the unseen. Imagine we are now observing a galaxy from a great distance. We watch the orbits of stars at every conceivable radius, from the inner bulge to the farthest reaches of the halo. Their speeds are our primary data. We then use the laws of physics to work backward, calculating the distribution of mass required to produce those observed velocities. The result is a stunning map. The luminous galaxy, the beautiful spiral we see in photographs, sits nestled at the heart of a colossal, roughly spherical halo of dark matter. This halo extends hundreds of thousands of light years beyond the last visible star, containing perhaps 10 times the mass of the entire visible galaxy. Our home, the Milky Way, is not a flat disk. It is a vast sphere of invisible matter, with the brilliant spiral structure embedded at its center like a jewel in a setting of unseen force. This dark matter halo is the true form of our galaxy. What we see with our eyes is merely the glowing tip of a deeply submerged iceberg. But what is it? We know it has mass. It interacts gravitationally. But it does not interact with light. It is transparent. It must be made of particles that are fundamentally different from the protons, neutrons, and electrons that make up our familiar world. This is not merely dark. It is something else entirely. Physicists have proposed a zoo of hypothetical particles. The leading candidate is a WIMP, a weakly interacting massive particle. As the name implies, it would have mass, but it would interact with normal matter only through the weak nuclear force and gravity, making it incredibly difficult to detect. It would be everywhere. A trillion of these particles might be passing through your body every second, yet they would slip through the atoms of your body like ghosts through a wall. Other candidates include axions, theoretical lightweight particles born from attempts to solve problems in quantum physics, or perhaps sterile neutrinos, elusive cousins to the neutrinos we already know. The truth is, we do not yet know. Dark matter is a placeholder name for a profound gap in our understanding. The search for a direct detection is one of the great technological challenges of our time. Deep underground, in abandoned mines and beneath mountains, physicists have built exquisitely sensitive detectors. They are shielded from cosmic rays and background radiation, waiting for the once-in-a-lifetime event where a dark matter particle might bump into the nucleus of an atom in their apparatus. So far, the silence from these experiments is deafening. The particles remain elusive, yet their influence is written across the largest structures in the universe. This is where our journey expands in scale, from single galaxies to the cosmos itself. Dark matter is not just a galactic glue, it is the cosmic architect. After the Big Bang, the universe was a nearly smooth soup of matter and energy. But it had tiny, random fluctuations in density. The gravitational pull of dark matter, acting like a scaffold, amplified these fluctuations. Normal matter, hydrogen, and helium gas was drawn into the gravitational wells created by dark matter. Without dark matter's gravitational pull, the universe would have expanded too rapidly for galaxies to form. The gas would have remained to diffuse, never collapsing into the dense clouds that ignite stars. Dark matter provided the initial structure, the skeleton upon which the visible universe was built. We can see this skeleton today. Through massive galaxy surveys, we have mapped the positions of millions of galaxies. They are not scattered randomly. They form a cosmic web, an immense network of filaments and nodes, with vast, empty voids in between. This web is not made of galaxies. The galaxies are merely the lit-up signposts along its strands. The web itself is woven from dark matter. We are living inside a structure built by an invisible architect. The evidence is overwhelming, yet the nature of the architect remains hidden. This is the frontier of modern physics. We are like explorers who have mapped a continent by feeling the wind that blows from it, but who have not yet set foot on its shores. As we conclude our journey for tonight, we are left with a universe that is far stranger and more wonderful than it appears. The majestic galaxies, the swirling nebulae, the brilliant stars, these are just a decoration. The underlying reality is a cosmos dominated by a mysterious, unseen form of matter that guides the formation of everything we hold familiar. Consider a single point of light, a galaxy, swirling with its billions of suns. It is a beacon of structure, a testament to the universe's tendency to gather, to collect, to build. For centuries, astronomy has been the study of such beacons. We have mapped the brilliant cities of the cosmos. Now, let your perspective shift. Pull back, farther, farther still, until that galaxy is just one speck among millions in a vast, web-like structure. You see the cosmic web now, a network of glittering filaments and dense clusters, a universe-spanning architecture of unimaginable scale. But your eyes are drawn away from the light. You are drawn to the darkness between the threads. Immense, spherical regions of near-total emptiness. These are the cosmic voids. They are not small. A single void can span hundreds of millions of light-years, a volume so colossal that our entire Milky Way would be a mere dust mote within its cavernous expanse. Within these voids, the density of matter drops to almost nothing. Galaxies are rare, lonely travelers. The few that exist are often isolated, strange, and pristine, evolving in solitude for billions of years. The space within a void is not just empty. It is emptier than the rest of the universe. It is a different state of being. Here is the profound mystery that will guide our journey tonight. These voids are not passive. They are not simply the blank canvas upon which the cosmic web is painted. They are dynamic. They are expanding. Their emptiness exerts a repulsive force, pushing the surrounding structure apart. The voids are growing, and in their growth, they are actively shaping the evolution of everything we see. We are living in a universe whose form is not just defined by where the matter is, but also by where it is not. The great emptiness is an architect. Our voyage will take us deep into one of these voids. We will fly through its hauntingly sparse interior, visit its lonely galactic inhabitants, and understand the forces that sculpted it. We will see how these vast nothingnesses hold the key to understanding the most powerful and most mysterious force in the cosmos, dark energy. This is a story about the power of absence. It begins with a map of the universe and a conscious decision to look away from the light and into the dark. Let us begin our departure from the familiar. Let us turn our ship away from the brilliant superclusters and point it toward the nearest great void, a region known as the boat's void. The transition is not sharp. There is no wall. It is a gradient, a slowing fading of the stellar populace. As we leave the filamentary network, the number of galaxies begins to plummet. Where once there were thousands of galaxies in a single field of view, now there are hundreds, then dozens. The space between them yawns wider, becoming a gulf of increasing blackness. The light from the web behind us begins to dim, becoming a distant, shimmering curtain of countless suns. Ahead, there is only an ocean of unbroken night. We are crossing the shoreline of the known universe, sailing into the empty deep. After a long journey, we find ourselves at the true threshold. The last outposts of the web are behind us. We are now in the interior of the boat's void. The silence here is not just an absence of sound, it is a perceptual weight. The sheer scale of the nothingness is overwhelming. If you were to float here, the nearest major galaxy would be so far away that its light would be a faint, insignificant smudge. The cosmic background radiation, the leftover heat from the Big Bang, would be the dominant source of light, a uniform, cold glow in all directions. The temperature here is marginally lower, a relic of the void's underdense nature. This is the realm of ultra-diffuse galaxies. The few galaxies that call the void home are often ghostly, ethereal things. They have vast amounts of dark matter, but their stellar populations are sparse and spread out. They are like wispy, transparent clouds of stars, having formed in an environment where there was little gas to coalesce into a dense, brilliant disk. They have evolved in isolation, untouched by the violent mergers and gravitational interactions that shape galaxies in the crowded clusters. They are living fossils, preserving a quieter, slower chapter of galactic evolution. But why do these voids exist at all? To understand that, we must journey back in time, to the very first moments of the universe. In the primordial fireball of the Big Bang, there were quantum fluctuations, tiny, random variations in density. These were the seeds of all future structure. Regions that were slightly denser than average had stronger gravity, pulling in more matter, eventually collapsing into galaxies and clusters. Regions that were slightly less dense than average had weaker gravity. As the universe expanded, these underdense regions were left behind, emptying out as matter flowed toward the denser seeds. The voids were born from these initial deficits. They are the negative impressions of the cosmic web. Over billions of years, they have been emptying further. Galaxies on the edges of voids experience a gravitational tug-of-war. The overwhelming pull is from the denser filaments and clusters, drawing them outward, away from the void's center. This is known as the void galaxy cross-correlation function, a technical term for a simple reality. Everything is being pulled away from the nothing. Downturn. The expansion of the universe is not uniform, it is faster in the voids. The low density of matter here means there is less gravity to counteract the inherent momentum of cosmic expansion. The voids are not just empty space, they are the engines of expansion. They are where dark energy, the mysterious force accelerating the universe's growth, finds its strongest expression. The growth of voids is, therefore, a direct measurement of dark energy's influence. By mapping the sizes and shapes of voids across cosmic time, we can measure the strength of this repulsive force. The voids are our laboratory for studying the ultimate fate of the universe. As we float here, in the heart of this immense nothing, we are witnessing the dominant force in our cosmos future. The galaxies and clusters will eventually be pushed apart by the growing voids. The cosmic web will stretch and thin. Over trillions of years, the universe will become a colder, darker, and ever more empty place as the voids merge into one ultimate, all-encompassing nothingness. This is not a story of destruction, but of transformation. The voids are not evil. They are a fundamental part of the cosmic cycle, as natural as the birth of a star. They remind us that the universe is not only about accumulation, but also about release, about the immense, powerful beauty of space itself. Our home, the Milky Way, does not reside in a void. We are in a filament, a cosmic metropolis. But we are surrounded by these expanding bubbles of nothing. Their growth is, ever so slightly, influencing the motion of our local group of galaxies. We are not separate from the voids. We are part of the same dynamic cosmic system. So, as you prepare for sleep, consider the void, consider the power of absence. The universe is not just defined by its brilliant structures, but equally by its vast, silent, and expanding emptiness. We exist in the balance between the two, in the temporary, shining structures between the growing voids,